Let's look at inverse trigonometric values. For example, let's find the exact value of inverse cosine of 1/2. Now be very careful here with this notation. This does not mean 1 divided by cosine x. This is just the notation for the inverse cosine function. If we meant this, we would have written cosine x to the -1 power. And by the way, there's another notation for the inverse cosine function that avoids this ambiguity. Inverse cosine of x and arc cosine of x mean the same thing. But this inverse cosine with the -1 here, this notation is more common. So what does this mean, inverse cosine function? If we think of the graph of cosine, this here is pi halves, this is pi, this is 3 pi halves, and so on. Over here is negative pi halves. This is negative pi. This is negative 3 pi over 2, and so on. Cosine is not a one-to-one function, is it? This is the graph of y is equal to cosine x. And remember that in order for a function to have an inverse, it must be one-to-one. So in order to discuss this function here, this inverse cosine function, what we do is we restrict the domain of cosine. And if we restrict the domain of cosine to the interval 0 to pi, for example, then cosine will be one-to-one on this interval. So we restrict the domain of cosine to the interval 0 to pi. And remember that the domain of a function is the range of the inverse. So we have the following definitions. We're working with this middle one here, the inverse cosine function. So y is equal to inverse cosine of x means that cosine of y is equal to x. And moreover, y is in this interval. This is the restricted domain of our cosine function, which is the range of our inverse function. So we're thinking backwards now. Our inverse cosine values will be angles. We're used to plugging in angles into the cosine function. Now they're the output. All right, so looking at our problem here, let's set y equal this inverse cosine of 1/2. This is equivalent to cosine y is equal to 1/2, where y is in this interval down here. So thinking of our unit circle, the cosine of this angle here, pi divided by 3, is equal to 1/2, because the x-coordinate of this point is 1/2. But also the cosine of this angle is also equal to 1/2. And this angle is 5 pi divided by 3, because the x-coordinate of this point is also 1/2. And the cosine of any angle coterminal with either of these angles will also be equal to 1/2. However, the only angle in this interval down here is this pi over 3, which would be our answer. So this is equal to pi over 3. And if we look over here at the green graph on the right, this angle here is pi over 3. And the cosine of it will be equal to 1/2. But also, all the y-coordinates of these points is also equal to 1/2, which means that the cosine of all of those angles, which corresponds to these points, will be 1/2 as well. But the only one in the interval 0 to pi is this pi over 3. All right, let's look at another example. Let's find the exact value of inverse sine of negative 1/2. Again, we have the following definitions, but now we'll be working with this first one here. So y is equal to inverse sine of x means that sine of y is equal to x, but moreover, y is in this interval, negative pi halves to pi halves. And let's graph the sine function to see why this interval works. So here's the y-axis, and here's the x-axis. Sine will look like this. Where this here is pi over 2. This is pi. This is 3 pi over 2. And so on. And over here, this is negative pi over 2. This is negative pi. This is negative 3 pi over 2. And again, y equal to sine x is not a one-to-one function. However, on the interval from negative pi halves to pi halves, for example, it is 1-to-1, isn't it? So on that restricted domain, sine will be 1-to-1, and therefore it will have an inverse. And remember, the restricted domain is now the range of our inverse. And notice that is a different interval than we just saw with the cosine function. In fact, on the interval from 0 to pi, sine is not 1-to-1. All right, so let's compute our value here. Let's let y equal to inverse sine of negative 1/2. This means we're looking for an angle y whose sine is equal to negative 1/2. Thinking of our unit circle, the sine of this angle here, which is 7 pi divided by 6, is equal to negative 1/2 because the y-coordinate of this point is negative 1/2. But also this angle here, which corresponds to 11 pi divided by 6, also has sine equal to negative 1/2 because the y-coordinate of this point is also negative 1/2. And the sine of any of their coterminal angles will also equal negative 1/2. However, looking down here in the table, what we need to do is find the angle in this interval that has sine equal to negative 1/2. Now, a very common mistake that students will make is they will think that this interval, negative pi over 2 to pi over 2, corresponds to any angle in quadrants 4 and 1. And so they'll answer this 11 pi divided by 6. However, 11 pi divided by 6 does not lie between negative pi halves and pi halves. So what we need to do is find the angle that is coterminal with 11 pi divided by 6, whose sine is equal to negative 1/2. And that angle would be negative pi divided by 6, which is our answer. So let's write that here, negative pi divided by 6. And let's look at that on this graph over here. This angle here is negative pi divided by 6. The sine of it will be equal to negative 1/2. But also the y-coordinates of all of these points here is negative 1/2. Which means that the sine of all of those angles corresponding to those points will also equal negative 1/2. But the only one in the restriction is negative pi divided by 6. So we have to be really careful when computing inverse sine values of a negative input. And this is the same thing with computing inverse tangent of negative inputs. So let's see an example of that. Let's find the exact value of inverse tangent of -1. Again, we have the following definitions. We'll be working with the last one here. So y is equal to inverse tangent of x means that tangent of y is equal to x, but moreover, y has to be in this interval, -π/2 to π/2. So let's take a look at the graph of tangent to see why this interval works. So y equal to tangent of x looks like this. Here's the y-axis. And this is the x-axis. Now tangent has vertical asymptotes at π/2, 3π/2, and so on, as well as -π/2, as well as -3π/2. And tangent looks like this. And notice that tangent is not 1-to-1. However, on the branch between -π/2 to π/2, for example, it is. So we restrict the domain of the tangent function to this interval, which then is the range of the inverse. So our answers to inverse tangent have to lie in that interval. So let's look at our example. Let's let y equal inverse tangent of -1, which means we're looking for an angle y such that tangent of y is equal to -1. However, y must be in that restricted interval. Again, thinking of our unit circle, the tangent of this angle here, or 5π divided by 4, is equal to -1 because the ratio of y to x here will be equal to -1. But also, the tangent of this angle, 7π divided by 4, is also equal to -1 because the ratio of y to x here is also equal to -1. And the tangent of any of their coterminal angles is also equal to -1. But remember, looking down here, we have to have our answer in this interval. And again, be very careful here. Don't just look in quadrants 4 and 1. That is, don't be tempted to answer 7π divided by 4. We have to find the angle that is coterminal with 7π divided by 4 that lies in this interval down here. And that angle would be -π/4, won't it? So let's write that up here. Our answer then is -π/4. And again, let's look at this over here on this green graph. So this would be the angle -π divided by 4. The tangent of it will be -1. But also, the y-coordinates of all of these points is also -1, which means that the angles corresponding to those points will also have tangent equal to -1, but none of those angles are in this restriction. So be very careful when computing inverse sine and inverse tangent values of negative inputs. Thank you, and we'll see you next time.